So, as we're looking today at rules for integration, all right, if you look closely at this, the reality is you actually know quite a few of these already. All right, first of all, if we have a constant, okay, you guys know that the derivative of a linear function is a constant. All right, so if we're taking the integral of a constant, notice we get a linear function. You can treat this one just like this second rule, the rule for x to a power. Okay, if you think of the constant like, like k times x to the 0 power, if I add 1 to the exponent, now I have x to the first, and then you divide by 1, you just have kx to the first. Okay, so that is one way to remember that constant. All right, then we also have our rule for x to the n, but we already saw why it does not work for n equal to -1, because if you add 1 to that, you have x to the 0, but then you're dividing by 0. So we have to have a better way of doing that, which brings us to this fourth one down here, and that is when the exponent is -1. Okay? When we have x to the -1 power, i.e. 1 over x, you guys knew or learned that the derivative of the natural log is 1 over x, but also the derivative of the natural log of -x ends up being 1 over x. So there's actually two different ways, two different functions that have a derivative of 1 over x. So as a result, when we take the integral of 1 over x, it's the natural log of the absolute value of x. Okay? And by the way, it needs to be the absolute value of x, because remember the domain for the natural log is that x has to be greater than 0. Okay? Now, we skip this one, e to the x. This is the nice easy one from derivatives. Derivative of e to the x is e to the x, so the integral of e to the x is e to the x. Okay, so that one's a nice one. So here we have these last two. Okay, these last two, the derivative of sine you know is cosine, so the integral of cosine is sine. Okay, you guys know that the derivative of cosine is negative sine. Alright, so if I took the derivative of negative cosine, I would have negative sine or positive sine. And that's how we get the rule for the integral of sine. The integral of sine is negative cosine. Okay? I will tell you at some point you will probably forget which one is negative which, and that's where our nice tool from Mrs. Barbag really comes in handy. Okay? Sine, cosine, negative cosine. Alright? So as you go down, you're taking the derivative. As you go upwards, you're taking the integral. Okay, so the derivative of sine is cosine, derivative of cosine is negative sine, derivative of negative sine is negative cosine. However, if I take the integral of cosine is sine. The integral of sine is negative cosine. The integral of negative cosine is negative sine. The integral of negative sine is cosine. Alright, so if you remember that, that's a great way to keep it all straight, especially with the negatives when you're switching from derivatives to integrals. Okay? So those are our basic rules. At this point, it's really just a matter of putting them all together. Okay? So for example here, I have 2 sine of x minus cosine of x. Alright? So sine, cosine, negative cosine. Alright? So if I'm taking the integral of 2 sine of x minus cosine of x with respect to x, here's where our rules come into play. Remember the rules that we learned last Friday say that if we have things that are added or subtracted, we can separate them, all right? And while you may not need to write it this way, at least mentally you can look at it this way. 2 times the sine of, or the integral of sine of x dx minus the integral of cosine of x dx. Okay? You could just think of it this way. So what's the integral of sine? Negative cosine, okay? Integral of sine is negative cosine, so this is a negative 2 cosine x minus, what's the integral of cosine? Sine. And then plus c. Don't forget your plus c's. Okay?
Could you view it just as negative, like when you're taking the integral, instead of having to separate it, you just go straight from negative cosine to negative sine?
Oh yeah, yeah.
And why again do we add the plus c?
We add the plus c because remember, if we were taking the derivative of this to get back to 2 sine minus cosine, it doesn't matter what constant you have, the derivative would be 0. So,
That's because the derivative of a constant is 0.
yes. Okay, how about B? If we're taking the integral of negative 2 over x plus 3e to the x with respect to x.
We're going to do it ln.
Okay, good, it's going to be ln. We can think of this as negative 2 times the integral of 1 over x dx. Okay? That's how you can see that in your head. Plus 3 times the integral of e to the x dx. Alright? So you're right, we have ln of the absolute value of x, which is now being multiplied by 2. So negative 2 times ln of absolute value of x plus 3 times, what's the integral of e to the x?
E to the x.
E to the x
All e to the x.
plus c.
Why are we putting dx? Like, why is it up here?
Well, it's just like when you took the derivative, you took the derivative of y with respect to x.
So we should write always like dx. If it won't write,
Yes.
it will be a mistake.
That tells us what we're taking the integral of, or with respect to. Because actually there's one thing you are able to take the integral, say, let's say you had, you know, I don't know, let's say 3x squared minus 5x with respect to x, but then you might evaluate that from negative 2y to 7y, and then you could take the integral with respect to y from like 1 to 5. That's what's known as a double integral, okay?
We're going to learn that.
No, we're not going to learn that. You'll learn that if you take like a multivariable calculus in college, okay? So, but that's why that's one reason why that dx is important. It tells us what we're differentiating with respect to. It's also important because remember those sums of the rectangles. The sum of the rectangles, this is the height of each rectangle. The dx was your width for each rectangle. So width times height gives us the area of the rectangle. Okay? Alright, so we have this plus c, and we're going to look at something to do with that in a sec, but one thing we do need to do here is if we have a product or a quotient like this, we're going to need to either multiply it out or do the division, just like we did with derivatives before we knew the product and quotient rules. Okay? The problem is here there's no product and quotient rule for integration. So you really have to FOIL it out on the left or split it up and divide on the right. Okay? So, for example, what am I getting if I FOIL the 3x plus 2 over x squared? 2 over x. So 9x squared, good.
Plus
6.
Plus 6.
plus 6
Plus.
plus 3x cubed.
No, plus another, yeah, plus 4.
Oh yeah.
Plus 6 plus 6 plus.
4 over x squared.
There we go. 4 over x squared. So I'm going to make that x a negative 2. Okay? So, kind of a strange one to FOIL, but you guys can handle it. Alright? So now we can take the integral of each part. So what's the integral of 9x squared? 3x cubed. Okay? 9x cubed over 3, right? So 3x cubed. What's the integral of 12?
12x.
12x. Okay? And then what's the integral of 4x and negative 2?
4x.
Negative
4x and negative 1 over negative 1. Okay, make sure you add to the exponent, okay? So this is going to be a minus 4 over x.
Why 4x and negative 1 over
Because
negative 1?
you have to do it over, you have to add 1 to the exponent and then do it over the new exponent.
Does that make sense?
We did for the 9x3.
Negative 2 plus 1 is negative 1.
Yeah,
Then you divide by the negative 1.
why divide by negative 1? Oh, because of the, okay, never mind.
Okay? Alright, you got it. Same thing here. We add 1, so now it's x cubed. We divide by the 3, and then we reduce 3x cubed. Okay? It'll come, it'll come. These just take practice, just like your derivatives did when you started doing those, okay? Now, when we're working with this second one, here, notice that it has a monomial in the denominator. If it had a binomial, we would kind of be stuck here. Alright? So, thankfully we have a monomial. We have x squared over x to the 1/2 minus 2 over x to the 1/2 dx. Okay? What is x squared over x to the 1/2?
Is x to the 4th?
No.
X to the 3/2.
X to the 3/2. X to the 3/2 minus 2x to the negative 1/2. Alright, so now we can find our integral. Okay? What's the integral of x to the 3/2?
X to the
X
5
fifths.
fifths x to the 5 over 2.
Good. 2/5 x to the 5/2.
Why 2/5?
Because you have to divide by 5/2. So you flip and multiply, right?
Ugh.
I know.
Negative
Okay?
9 or minus 2x to the
Or x to the 1/2.
2x to the positive 1/2
Times by 2. Right?
times 2, or divided by 1/2, okay?
Negative 4.
4x.
So,
Negative 4x.
so good, negative 4x to the 1/2. And then you've got a plus c. Okay? Does that make sense? Okay? Does anyone have any questions?
How did you get from x squared divided by x to the 1/2 to x 3 over 2?
Well, remember, if you're dividing, you subtract the exponents.
Oh, you just subtract.
So yeah, 2 minus 1/2 would be 1.5. Okay. Now, one thing I want to make a comment about, the answers in the back of your book, when you're doing practice problems, when you have that 1 over x part, the answers in the back of the book for some reason always leave out the absolute value of x. Okay? Don't. Alright? please make sure that you include the absolute value of x in your answers. Okay? So, looking at the formula booklet, okay, they even leave it out on the formula booklet for some reason. Okay? But you should not. They actually, though, stipulate that x has to be greater than 0. So, it's kind of a technicality, but they just kind of redefine what x is allowed to be, so that's why they leave it out. But to prep you better for college or AP if you do that next year, just get used to putting the absolute value in there, okay? Alright.